Basics on solving algebraic equations, but first a quick review on order of operations. Do you remember what it is? What is it?
It's multiplication and division first, and then addition and subtraction second. But if anything's in like parentheses or in like a fraction bar, then you do that stuff first.
Okay, so even before the multiplication addition, right? So I'm going to throw a few more in there, and I like to think of it as stair steps, literally, right? So when my kids were little, or when you guys were all little, your parents very unlikely let you just jump from the top step way up here all the way down there, right?
You'd have a broken bone.
Right. It's not very smart to just skip steps. So when you're talking math, the very first step in order of operations is there's a mnemonic. Do you know the?
PEMDAS.
Yeah, PEMDAS. PEMDAS. These become my stair steps. So P is first. P stands for parentheses. So that's the first thing you need to see. If it's there, you do it. If it's not, then you go on to the next step, which is what? So we got that one. Exponents. So it's something like this right here, right? Then what? This is slightly tricky, actually. What's the next one?
Multiplication.
Not just multiplication. And division. And here's the thing. I'm going to cross them both off. It's multiply and divide, but from left to right. So if divide happens to come first, you do it first, okay? Which then kind of is the same thing as the last step, which is what?
Addition and subtraction.
Right, addition, subtraction. Addition, subtraction.
I didn't make my steps big enough.
They always tell you draw big, right? You got to give yourself space to write.
It just doesn't happen.
Think if it helps, Carson. Oh my gosh, I keep calling you Carson.
I'll just name him Carson for now. We'll change his name.
Your name's Cameron. Your name is Carson for the day.
Use this.
Okay.
Cameron, think of my screen as your whole sheet of paper. So if I'm drawing across my whole screen, it's going to be across your whole paper. So I have this order of steps. So completely unrelated to math. Let's say you were invited to your best friend's wedding, right? You want to give your best friend the most special gift, and you want to present it in the most special way. So think like an old lady. What might be the first thing you do to a gift if you want to wrap it really specially? Put it in what first?
A gift bag.
Okay, what are you going to put in the gift bag though with it?
Tissue paper.
tissue.
Oh, so maybe tissue paper first. So here we have our fun little, what is it going to be, a bow? We'll make it a bow, right? Here's my bow. I'm very artistic.
I like your bow.
I thought you meant like a bow and arrow.
There's my bow. So we know what the present is, right? We're going to wrap it in tissue paper, right? So the green is my present. The blue is my tissue paper. And then what else are we going to wrap it in? Don't do gift bag. Do more complex than gift bag.
Wrapping paper.
Well, but what do you going to put the wrapping paper on top of?
Box.
Oh, so we need a box. We need a box. Then what do you put on the outside of the box?
The wrapping paper.
The wrapping paper, sure. Okay, so we're going to have pretty wrapping paper on the outside of the box, right?
Should have just brought all the colors over here.
Wrapping paper. And then the very almost last thing, maybe. What would you put on top of the wrapping paper?
Another bow.
A bow, right. Okay, so let's put a beautiful bow on top, right? And that's got to crisscross the whole package this way and this way, like my mom's fancy bows that nobody can ever get off the package, right? So there's the bow.
I was thinking like a sticker or something.
Like a name label.
Okay, so the very first thing we had to do was we got the present. Then we put it in tissue paper. Then we put it in a box.
Whoa.
Then we put wrapping paper on. Then we put a bow on the top, right? You can kind of think of this as your order of operations. When you know everything, you're the gift giver, you know what's inside. you're going to follow the order of operations to present somebody with a beautiful gift. So think of it like as, let's say I've got some kind of crazy super complex thing like 3 minus 2 all squared, take away 4, all divided by 7, something crazy, right? This is kind of like you know everything. You're going to come up with your beautiful present all wrapped up neatly and done. Okay? But what if you're the recipient of that gift? You get that gift. You want to find out what's inside, right? What's the first thing you have to undo?
The ribbon.
The ribbon, right. You have to go undo what I did last. Then what do you have to go undo?
Second to last.
Wrapping
The second to last, then the wrapping paper, right? So when we're undoing it, I'm going to switch to, I don't know, some other new color. I got to create something here because we've used all the colors that I've got. What color have I not used? Magenta, red, burgundy, whatever that is. Okay, so when we're undoing, when we're unwrapping, we have to undo the bow first. So really we're undoing number 4. Then we're undoing number 3, right? Then number 2, then number 1. So we finally get to find out what's inside. It's the same kind of concept with solving equations. Steal this for a second. So when you're solving an equation, you're trying to find out what the variable is. I know you might disagree with me, but think of the variable as your gift, right? It's going to be like, what are you looking for? What is somebody giving you? That's the whole, look for some equations. No great equations popping off. Okay, so let's just start simple. Did you guys need this for a second yet?
Yeah.
Sorry, I'll leave it there. Let me know when you're ready.
I'm good.
This is that pause button.
Okay, I'm ready.
Are you good, Emma?
Yeah.
Okay.
Yes.
You good, Carson?
Wait, what?
What?
That's the box and the wrapping paper, both 3.
Where?
Oh,
Oh, I did that wrong. I'm sorry. You caught my mistake. I owe you a piece of candy.
I didn't know.
There's 4, and there's number 5. So in here, I need to add a number 5. I thought that seemed a little odd. So when you're unwrapping, yeah, you go backwards though. The whole idea is go backwards, right? So if I think back to this, when I'm solving equations, or sorry, start with when I know all the numbers, I'm going to go this way down the stairs, right? But when I don't know all the numbers and all the things that go along with it, I'm trying to find the value of x, I need to work back up the steps, right? Trying to give you some visual type cues to help you remember steps to solving equations. So start super simple. Let's just start with something like x plus 4 equals 10. Super simple. This is like the gift where you just threw it in a bag and said, here you go. So there's really only one thing to undo. What do I have to undo?
The 4.
The 4. So if I'm like when I put it in the bag, you're doing the opposite. You're taking it out of the bag. So right now I'm adding a 4. What's the opposite of add 4?
Subtract.
Right. Show it on both sides. Get used to showing it because it helps you. When you're super comfortable, do it in your head, I don't care. So we have x left because the 4 take away 4 is just nothing. 10 take away 4 is 6. Simple, right? You can always check these. How do you check them?
You
With
can
the
add,
calculator.
No, not with a calculator.
you can add 4 back to 6.
Right, because you're saying x is 6. That's your present. So if you take that and put it back in here, it better give you your final answer. 6 plus 4 is 10. Okay, make it a little bit more complex. I have no guarantees of how pretty it will be because I'm just making numbers up here. So what if I had something like 2x plus 4 equals 10? Well, now your present got a little more complex. If you knew x, let's just pretend you know it for a minute and make up some number. I don't know, a 2. I'm making that up. It's not accurate. What would you do if you knew that that was a 2? Bless you. Order of operations tells you to do what first?
Parentheses.
Parentheses. In this case, the parentheses really you're doing nothing inside of, so the parentheses actually is standing for multiplication. So in this particular equation, you have multiplying going on here, and you have addition going on. Think back to our steps. If you know it all, what do you do first? going down the steps. Do you have any parentheses to do inside of?
No.
Did you have any exponents?
No.
Do you have multiplication and division?
Yes.
So that's what you would do first if you knew x. Then you would do the subtraction. So we don't know our gift. We're trying to find out what it is, so we need to work backwards. Right? So if I'm going back to this one, what's the first thing I need to undo?
The 4.
The 4, and that's like your tissue paper, if you want to call it that, right? Or sorry, not your gift bag. So I'm going to take away the 4 because that's the opposite of add 4. And I'm left with 2x and on the other side 6, right? You can also think of the equal sign as a balance scale where you have like a little dish here, right, on a balance scale. If you take something off here, let's say you take away 3 here, this side is going to go down, right, as far as balance of weight type stuff. If you don't want it to go down, you want to keep it even, you also need to take away 3 here, and it will balance back out again. Does that make sense? So whatever you do to one side, you need to do the same on the other. All right, last thing, I need to take it out of the package. So I need to undo the multiplication. How do you undo the multiplication?
Divide.
Right, divide. I know I told you I'm starting super simple, right? What's that?
That's what
Okay, so you should have x equals 3, and you could check it, right? You could plug it back in, so you could say check being 2 times 3 plus 4, does it equal? When I'm checking, I tend to put the question mark there so that I know I'm making sure. Is it true? Well, 2 times 3 is 6, plus 4 is 10. So yes, it checks out. Ready for more complex? I'm going to try and go fast to get to the way more complex stuff that you are facing. So something like, again, I'm making it up, so I don't know how pretty it'll be. 5y minus 7 equals, I don't know, 2y plus 10. This might not be very pretty. This is where it gets a little bit more complex because you have y's on both sides. The tendency that I've seen is for students to get the numbers, the constants, like 7 and 10 to one side. I would recommend you get the variable to one side first, okay? Get the variable to one side so you only have one side dealing with variables first. So what would I do first? Which one do you want to get rid of, the 2y or the 5y?
Subtract the 2y.
Why the 2y?
Because if you subtract the 5, you're going to get a negative.
Is that okay? It's okay.
It's not fun, but it's
Exactly.
okay.
I do the same thing. I think ahead a little bit, enough to think, I want to leave my variable term positive just because. Doesn't necessarily matter, but sure. Okay, so 5y take away 2y's leaves you with 3y's. And I'm saying y's because it's literally saying you have 3 of those things. And you have 3y take away 7 equals 10, which left. Now it looks like what we just did up here of, I have a 2-step equation it's called. So now what do I need to undo?
The 7.
The 7. So I need to do what?
Add.
Add. That's the opposite of subtract, so add 7. So I have 3y equals 17. Am I done?
No.
Not quite. Last step,
Divide.
divide by 3. So I end up with an improper fraction, which in my book, you can leave it this way. If you're graphing and you want slope, a fraction is way more helpful than a mixed number. If you're graphing a coordinate point, like you have this and you need to know how far to go over or how far to go up, actually a mixed number is more helpful. So it depends on the situation. As long as it's mathematically accurate, I personally don't care. If I'm doing a mixed number, 3 fits into 17 5 times evenly with 2 left over. So you have 5 2/3. So you could more easily graph on a point 5 2/3. But do me a favor. Leave it as a fraction. Don't give me a decimal. Fractions are actually a lot easier to deal with in most cases, not always. Okay, ready to be more complex?
Why not?
Again, it may not be pretty, but that's okay. We can still do it. Okay, so something like 2 times the quantity of x minus 4 equals 1/4 x plus 10. Who knows how ugly this will be. Okay. What can I do with this? There's a couple of options on how I can solve this. Any ideas?
You distribute the 2.
That's one way. I can distribute the 2 first. So I can share that 2. So I could say 2 times x is 2x. And I'm coming over to the side because I might quickly go the other way shortly. 2x take away, because that's really, I think of this not just as take away, but as a negative. 2 times negative 4 is negative 8. And the other side still stays the same. 1/4 x plus 10. Quick side note. 1/4 x can also be written as x over 4. Do you see why?
Because there's just a 1 on top.
Yeah, so really there is an understood 1, it's called. 1 times x there, right? And you can pull that fraction out to be in front of it. Just a quick side note. Okay, so I'm back to kind of like where I was in the previous example. I would like to get the variables to one side, but there's a fraction in there. Do we want to deal with fraction now or later?
No.
Like, do you want to subtract 1/4 x, or do you want to get rid of the fraction?
Be rid of the fraction.
You want to be rid of the fraction? Okay. So if I have 1/4 of something, how many of them do I need to make it a whole?
4.
I need 4 of them in this case, right? There are fourths, so I need 4 of them. So if I multiply this whole side by 4, what's going to happen to that 1/4? Poof! It'll go away. But if I do it here, think of your scale. What do you have to do to the other side? Multiply by 4 also. This is just one strategy. So we need to distribute that 4 on everything. So I would have 8x, take away 32. This is where it's helpful to know your facts. If you don't, grab a calculator, but if you do, great. It just goes faster. 4 times 1/4 is just 1. So I have x, just 1x, plus 40. So now it looks a lot more like we had a minute ago. What can I do?
Subtract the x.
Sure, subtract x. So I have 7 x's now. Because when I'm taking away that x, I'm not literally taking away that portion of the number. I'm not taking off the x. I'm taking away one of the x's. I see that as a common mistake sometimes. Those x's just disappear, but they didn't. So I'm unwrapping my present, right? I'm going backwards through the steps. Sometimes I got to go forward a little bit to go backward. Okay, now what?
Add 30.
Yeah. Plus 32 plus 32. So I have 7x equals some very large number. 72, right. And then I'm going to need to divide by... Oh, yeah. I was thinking ahead of something else. Yeah, divide by 7. So x equals 72 over 7, which could just be 10 and 2/7, or leave it as that. Kind of ugly, but it's dealable, right?
Mm-hmm.
Do you want to see a different method for doing this or not really? I'll do it on a different one where I don't have a fraction involved, because the way we did this one I think is probably the most straightforward. Okay. I don't think I'm going to throw any in with exponents today, maybe another time. But I do want to do this one. Let's see how ugly this will be. 3/5 x plus 13 equals 9x minus 7. I don't know if this is going to work well or not, but we'll try it. Okay. You know what I'm going to do? I'm going to get rid of this right now. Okay? So it's just going to be equals -7. Sorry. Make it a little simpler for a reason. Okay, so thinking of my gift idea, my gift is right there. It has been wrapped in tissue paper and in a bag. What's the first thing you want to do? Because again, if you know your gift, you do the multiplying by that fraction first, then you do the adding, right? If you know it, you go in that order. Here's number 1, and then here's number 2. If you're unwrapping it, you have to go in the backwards order. You have to undo the 2, then the 1. So undo the 2. What do I do?
We subtract 13.
Right, take away 13. So I'm left with 3/5 x equals negative 20. How do I get rid of that 3/5? There's a couple of ways you can look at it. Just a little bit ago, I had this 1/4 x, and you all said, multiply it by 4, because 4/4 would give you a whole. What kind of size fractions am I looking at here? What are those called?
A fifth.
Fifths, right? I'm not asking rocket science. I'm asking the stupid questions, so I expect simple answers. That's okay. So I have fifths, but I also have 3 of them. We can do it in 2 steps, or we can do it in 1. I don't care which way. You want to do it in 2 first?
Sure.
Okay, we'll do it in 2 first. I'm going to get rid of my arrow here. So I want to get rid of the fifths. How do I get rid of the fifths? What do I do?
Multiplied by 5.
Multiply by 5. If I multiply by 5 on both sides, I end up with negative 100. I'll do the hard part. Negative 100.
It's not hard.
That's my sarcasm. Okay, so but the other side, what happens with those?
3x.
It's just 3x, right? Like here in the 4th example, those 4's cancel out. These 5's cancel out to leave you with just 3x equals, there's a giant equals in there, sorry, equals 100, negative 100. Now you would just need to do what? Divide by 3. So I just have x equals negative 100 over 3. I'm going to leave it at that. I don't really care what the fraction is. Negative 100 over 3. I didn't think through fast enough, well enough. I was close. Okay, the other option. I'm gonna jump back and I'll rewrite from this step, just so you see the other way of doing it in one step. If I have 3/5, and you know what, I'm gonna change colors so you realize it's the same thing, but it's a different approach. So if I have 3/5 x equals negative 20, that's where we were at when we said 1 step or 2. So if I look at all that we did here, I multiplied by 5, but I also then divided by 3, right? What if I do that in one step by saying, we'll do this one, times 5, but also divide by 3? What happens?
The fraction goes away.
The fraction goes away, yes. And if I have to do it to the other side also, times 5, divide by 3 at the same time. These 3's cancel, because really it's 3 divided by 3 is just a ginormous 1. It doesn't go away entirely. It's not 0, it's 1. And 5 divided by 5 right here is also 1. And then you could go through and say, well, 1 times 1 is just 1 over 1 times 1 is just 1. And 1 divided by 1 is just 1. 1x. Did you follow through what I was doing with that?
Mm-hmm.
Okay. And then I can deal with this ugliness. I can put that negative 20 over 1, right? Because anything divided by 1 is itself. And then I can simplify this fraction. Well, there's not much I can do with the 1 and the 5 or the 1 and the 20. The 1 just makes it a fraction, so I can think about it that way. Can I simplify anything with a 3? Are there any factors of 3 up here? Can anything be divided by 3? I see you shaking your head, but you got to say no so that it can be recorded. Right. Okay, so no. So all I can do is say negative 20 times 5 is that negative 100 still. And it's still all over 3. So the one-step approach is, I'll rewrite it so you can see it a little bit more clearly. If I had 3/5 x, the one-step approach is to multiply by what's called the reciprocal, where you flip it. If it was negative, it still needs to be negative. Why?
Because
What's negative times negative?
positive.
Positive. And you want to be left with a positive x. Does this make sense so far? Okay, so far so good. Anything in particular you want me to go back to and explain a little bit more of? No? Good? Okay. Then I'm going to stop for now. I might add more if I can find some better examples, but I don't want to waste a whole bunch of recording time to find examples. Good?